Good day! I am here to discuss on how to use Weka in classification with the help of a dataset coming from our professor. The dataset is Cavite Coffee Beans dataset, 80 samples each class. The content of this PowerPoint is prepared by Dr. Edwin R. Arboleda, Doctor of Engineering. I am Mark Ryan B. Hermogino from BSECE 3-1 with student number of 2019-11100, and I will be reporting the use of Weka in classification. So what is Weka? Weka is a collection of machine learning algorithms for data mining tasks. It contains tools for data preparation, classification, regression, clustering, association rules, mining, and visualization. Found only in the islands of New Zealand, the Weka is a flightless bird with an inquisitive nature. The name is pronounced like this, and the bird sounds like this. Weka is an open source software issued under the GNU General Public License. On the right side, we can see the logo of the Weka application. So Weka is based from a bird in New Zealand. The software is open source, meaning it is free and accessible to everyone. Exciting and potentially far-reaching development in computer science is the invention and application of methods of machine learning, ML. These enable a computer program to automatically analyze a large body of data and decide what information is most relevant. The crystallized information then be used to automatically make predictions or to help make decisions faster and more accurately. Data sets. These are important to process the data and information in the Weka application. The sets are also found in the website of Weka. Some examples datasets for analysis with Weka are included in the Weka distribution and can be found in the data folder of the installed software. So the miscellaneous collections of datasets are found in the docs under resources and datasets. An example of the dataset from the website of Weka is a jar file containing 37 classification problems originally obtained from the UCI repository of machine learning datasets, UCI jar 1190961 bytes. We can also gain a dataset from our professor. Let's go to Google Scholar and search our professor's name, Edwin Arboleda. We can see here his profile, Edwin Arboleda, and here are his researches. We can pick some researches and take its dataset and try it to sample in the Weka application. So these are the steps in using Weka. I will now be discussing the first step. First is go to your browser and search for Weka. Here I used my Google browser in searching Weka and it shows the first result, Weka 3 data mining with open source machine learning. Let's click on the first result and it will be prompted into the Weka's web page. Weka 3 machine learning software in Java. Weka 3 is a collection of machine learning algorithms for data mining tasks. It contains tools for data preparation, classification, regression, clustering, association rules, mining, and visualization. So let us get started. The Weka website also contains projects, software, book, courses, publications, people, and related. Let us first, before downloading or installing the application, let us take a look for the requirements of the desktop application. The following matrix shows the minimum version of Java is necessary to run a specific Weka version. The latest official releases of Weka require Java 8 or later. Note that if you are using Windows and your computer has a display with high pixel density HIDPI, you may need to use Java 9 or later to avoid problems with inappropriate scaling of Weka's graphical user interfaces. So we need to assure that the Weka system requirements is compatible with the features of our computer or laptop. So this is a desktop application. It only works for laptop and computers. So after checking and making sure that it is compatible, we can now install our application. Let's go to downloading and installing Weka. Go to Docs. There are two versions of Weka. Weka 3.8 is the latest stable version of Weka, and Weka 3.9 is the development version. New releases of these two versions are normally made once, twice, or year. For the bleeding edge, it is also possible to download 90 snapshots of these two versions. The stable version receives only bug fixes and feature upgrades that do not break compatibility with earlier releases. With the development version may receive new features that bring compatibility with its earlier resources. Weka 3.8 and 3.9 features a package management system that makes it easy for Weka community to add new functionality to Weka. The package management system requires an internet connection in order to download and install packages. So we will choose the stable version to avoid bugs and errors. Weka 3.8 is the latest stable version of Weka. This branch of Weka only receives bug fixes and upgrades that do not break compatibility with earlier 3.8 releases, although major of the new features may become available in packages. There are different options for downloading and installing it on your computer. So it can be downloaded on Windows or Apple computer. If you are you have to choose if your operating system is Windows or Mac. So my laptop is using Windows, so I will be clicking on the Windows download button. Click here to download the self-extracting executable for 64-bit Windows that includes a sole 64-bit Open JDK Java VM 11. The file downloadable is named as Weka 385 Azul Zulu Windows.executable with 124.6 megabytes. So after clicking the download, we will be redirected to this page. Weka, machine learning software to solve data mining problems. Brought to you by LB, Farfset, MBA Major, and Weka. So let's click now let us now wait for the download to finish, and then let us click on the executable file and install the program. After installing the program, the web page will be updated and will say thank you for downloading Weka. You can be updated and get information when you subscribe to their website by placing your email address. So Weka application sometimes do not show an icon on the desktop, so we have to search it in the Windows search bar. Next, let us search for Weka in the search menu and click on the Weka 3.8.5, which is the version of Weka we downloaded in the app version. Now, let us now open the program. It says that Weka GUI Chooser. Weka has a package manager that you can choose to install many learning schemes and tools. The package manager can be found under the tools menu, and then let's click buy. So this is the interface of the program of Weka. The Weka from the University of Waikato. A Weka is a native bird from New Zealand. So the logo of Weka is coming from a real-life bird. Next, we will be needing a dataset in Weka. So this dataset is given and instructed by our professor to be used. Cavite Coffee Beans dataset, 80 samples each class. This is in Excel format. To use this data, we need to convert the Excel file into CSV file. Let us choose the CSV UTF-8 coms delimited. Let's select the CVS file and save it. After saving, we will see that a note, possible data loss. Some features might be lost if you save this workbook in comma delimited CSV format. To preserve the features, save it in Excel file format. It's okay because this file is what we'll be needing in the following steps. Next, let's go back to the application of Weka. In the Tools tab, let us click in ARFF Viewer or simply Ctrl A as a shortcut key. Now we will see a new window open up. Let us click on the File and Open or simply Ctrl plus O. Let us search for the folder containing the CSV file. In order to see the CSV file, let us click the file type as CSV data files.csv. Now let us select the CSV file and open it. This is now what we will see after opening the CSV file. We can see here the numeric data. There are area, perimeter, equivalent, roundness, and class. Now, the next step is to convert this file into our file. Go to File, click Save As or simply Ctrl-Shift-S. Let us save as this CSV file into ARFF data files.arff. So let us now save it. The file is now saved in the folder we have chosen. Okay, now let's now close the ARFF viewer and go to the home page of the website, the application. So in the application, we will click the Explorer. It has different types. The application has different types: Explorer, Experimenter, Knowledge Flow, and Workbench. But first, let us click on the Explorer to classify data. In the Pre-Process tab, click on Open File. It opens a set of instances from a file. Let's select the RF file we have created. The Cavite Coffee Beans dataset, 80 samples each class. C. With the file extension of ARFF data files. Let us now open it and we can see here the area, perimeter, equivalent, roundness, and class. This shows the current relation and selected attributes and the type of data. Here are the statistics and values. Let us click to visualize all. Here are the plot or the diagrams showing the area, perimeter, equivalent, roundness, and class. Now, let's go to classify, where we will do the classifier. Let us choose a specific classifier. But first, let us change the cross-validation folds into 4 in order to test 60 and 20. 60 for the attributes and 20 for the testing. The percentage split is 66%. Here, after clicking on the classifier, we can see the definition or description of the classifier we have pointed at the cursor. For example, the default classifier prompted after clicking the classify is the 0R, classes for building and using a 0R classifier. Predicts the mean for the numeric class or the mode for a nominal class. Capabilities. Class, binary class, data class, missing class values, nominal class, numeric class. Attributes, binary attributes, data attributes, empty nominal attributes, missing values, nominal attributes, numeric attributes, relational attributes, string attributes, unary attributes. Interfaces, sourceable, weight, distance, handler. Additional, minimum number of instances, 0. So it is important, the description is important for us to choose the right and accurate classifier for our dataset. Now let's try to start and run the classifier. Here is the run information of the class and the classifier output. It shows that correctly classified instances are 80 with 32.9218%. The incorrectly classified instances is 163 at 67.0782%. So it means it has a low correct instances and high incorrect instances. So this classifier is not accurate for this type of dataset. Let us now choose another classifier of bias in BiasNet. It shows that there is 223 or 91.7695% is correctly classified in the instances. So it has high percentage of correct values. Next is the bias naive bias. It shows 225 correctly classified instances at 92.5926%. Let's try another more. Bias naive bias multinomial test. The correctly classified instances are 80 at 32.9218%. So it has low classification. It's better if we try all types of classifier possible to find the efficient and accurate classifier for the data set chosen. Let's try the bias naive bias updatable. It has 225 classified correct instances and 92.5926%. Now let's try on the trees group. Trees for decision stop. Correctly classified instances is 155 at 63.786%. So it has average correct instances. Let's try trees J48. It has a 230 correctly classified instances at 94.6502% accuracy. Let's try trees LMT at 127 correctly classified instances at 93.4156%. Let's try trees random forest at 227 correctly classified instances at 93.4156. And let's try trees random tree at 157 correctly classified instances in 64.091%. So, in conclusion, the trees J48 has the highest accuracy and is the best classifier for our dataset because it shows the highest accuracy of 94%. are the other types of classifiers. It's good to know all of them. The classifiers under the bias group are biasnet, naive bias, and bias network learning using various search algorithms and quality measures. Bias network classifier provides data structures, network structures, conditional probability distribution, etc., and facilities common to bias network learning algorithm like K2 and B. For more information, let's see this link. Capabilities class, binary class, missing class, nominal class, attributes, binary attributes, empty normal attributes, missing values, normal attributes, numeric attributes, unary attributes, interfaces, drawable, weight distance handler, and additional number of instances 0. So in the meta group, AD boost M1, attribute selected classifier, bagging, classification via regression, cost-sensitive classifier, CP parameter selection, filtered classifier, iterative classifier optimizer, logiboost, multi-class classifier, multi-class classifier data pool, multi-scheme, random commitive, randomizable filtered classifier, random subspace, stacking both weight distances handler wrapper. For the miscellaneous input map classifier or serial classifier. Next, in the rules, decision tables, ARIP, 1R, part 0R. Under trees, decision stamp, holding tree, J48, LMT, random forest, random tree, ref 3. So here are the examples of the classifiers offered in the Weka application explorer. Let's take a look for the plot matrix of the dataset we have inputted. Let's now click on the Visualize tab and we can see the class roundness, equivalent, area, perimeter, equivalent, roundness, and class. Here we can see the plot size and the plot and graph of the dataset we have entered. So we are now done and we can now save the changes and make notes of what we have learned in the dataset using the classifier of Weka. We can now close the window as soon as we are finished. Here are my references. The YouTube channel of Edwinus Prime. Here is the link. A.B. Frank, Mark A. Hall, and Ian H. Witten in 2016, the Weka Workbench, online application for data mining, practical machine learning tools and techniques, Morgan Kaufman, 4th edition in 2016. Here is also the link of the Weka website. If you want to learn more, you can search for this. Thank you for watching and God bless. I am Marco and B. Hermogino from BSECE 3-1 2019-11100. Have a nice day. I hope you learned a lot from me. Thank you.